So this question uses the elimination that we just did, right? You could use substitution if your heart is stuck on substitution, or if you even remember what substitution is. You can use substitution. However, substitution sometimes forces you to have fractions, and which make people cry inside. So usually I just stick to elimination, because then you're not forced with big fractions often, unless you're substituting back in a fraction of some sort. So we have the sum of the first two terms of a sequence is 19. How could I represent the sum of the first two terms with a letter? And a number, perchance, that's low. T1 plus T2, or S, S2. So I could represent it with S2, because that would be the sum of the first two, right? T1 plus T2 would be S2. So S2 is 19. And then the sum of the first four would be S4 is 50, not 15, which is what my brain wanted to write. 50. What are the first six terms? Well, if I gave you T2 and T4 and told you it was an arithmetic sequence, it wouldn't be as hard, right? You could kind of like guess and check to figure out what number would fall in between. However, this means the first two add to 19, and then the first four add to 15. Well, what could add to 19? You'd have to try and figure out what arithmetic sequence of numbers. Well, it could be like 1 and 18. It could be 2 and 16. There's a lot of choice, right? So guess and check, probably not going to be the quickest for this. Even though this question is horrendously long when you do it the right way, it still is going to be less time most of the time than if you just guessed and checked, okay? So they want to know, what are the first six terms of this series, and the sum and sums to 20 terms, and the sum to 20 terms. Got a feeling I can read. So the first six terms, well, we're going to have to figure that out. So what you always do is, when you're given the sum of two terms of an arithmetic series, I guess, you fill it into this formula. We're not going to know two things in this formula. We know n, because n is 2 for the first one. We know Sn, because S2 would be 19, but we don't know T1 or D. When we did elimination, we didn't know X or Y. Same thing, right? T1 could be X, D could be Y. So it's the exact same thing, but we're not going to know two unknowns, okay? So when you don't know two unknowns, you're going to have to use elimination to find it. So we fill it into this formula. You don't fill it into the other sum formula. It won't help you. Things will eliminate. It will not be fun, okay? Because we need D and T1. So let's try it out. So for S2, it equals 19, and for S4, it equals 50. So we go S2 equals, we're just filling in the formula, 2 over 2, 2T1, I don't know T1, plus N, which is 2 minus 1, D, I don't know D. Now, most people get to this point and they're like, okay, this isn't bad. What do they forget to do? What else can you fill in? S2. You can fill S2 in for 19, right? Don't forget to do that. So that's the common error, is that people forget that you can fill that S2 in for 19 because the sum of two terms is 19. So we have 1. I don't need to write it. Then 2T1 plus 1D, so plus D. So how would I rewrite this equation? 2T1 plus D equals 19. And then it's in the exact same format as our X plus Y equals number format we just did, right? Seeing the connection between what we just did and this? Okay, try it for S4 now. So we go S4 equals 4 divided by 2. So now this one won't eliminate right off the bat. It'll be a little more work. 2T1 plus 4 minus 1 D. So we know S4. They told us the first four terms sums to 50. So 50 equals 2. Now that 2 doesn't go away like the 1 did on the previous one, right? So we're actually going to have to distribute that 2 in. So we have 2t1 plus 3d. Now you have to put the 2 into both. So 50 equals 4t1 plus 6d. I don't know. It's actually recording it. Okay, so then we have 4t1 plus 6d equals 50. Okay, now we just take those two, we drop them down, and we solve by elimination. So 2t1 plus d equals 19. 4t1 plus 6d equals 50. I'm going to choose to make the t1s the same, but could I have made the d's the same? Absolutely. So -2, -4t minus 2d equals -38. And then 4t1 plus 6d equals -50, or equals 50. When we add them, these cancel, and I'm left with 4d equals 12. 4d equals 12, divide by 4, d equals 3. So then I substitute d equals 3 in. However, if you would have gotten the d's to be the same, then you would substitute t in, right? So it doesn't matter. It's up to you. So I'm going to use the first one. 2t1 plus d equals 19. D is 3, so 2t1 plus 3 equals 19. Subtract my 3. 2t1 equals 16. So t1 equals 8. So they want the first 6 terms. That was what our goal was, right? They wanted those first 6 terms. Now we can give it. We have the first term. It's what? 8. And it goes up consistently by what? What's my common difference? 3. So I get 8 plus 3 is 11, plus 3 is 14, plus 3 is 17, plus 3 is 20, plus 3 is 23. Does this make sense? 8 plus 11 is 19. First two sum to 19. 8 plus 11 is 19, plus 14 plus 17 is 50. Makes sense, right? From what they said. Now they want the sum of the first 6 terms. Well, didn't it say sum of the first 20? No. What are the first 6 terms of the series? And the sum to 20. So we don't want to find sum of 6. That's a typo. Come on, Lepp. First 20 terms. Yeah. Yes. So we're going to find S20. Do we use the first sum formula when we know D, or do we do the last sum formula where we know the last term? Do we even know the last term? Do we know what T20 is? No. So we have to use the first one. So we're going to go S20 equals 20 divided by 2. 2. T1 was 8 plus n minus 1. So 20 minus 1. And D was 3. So we get 10 times 16 plus 19 times 3 is 19 times 3, 27. No, not even 57. And we get 10 times 60, 73. So 730? We agree? Like I said, at some point, if you catch a mathematical error, please stop me. I do make mistakes. Does that make sense? So we have here, in an arithmetic series, T30 equals 58, and S30 equals 1095. Find T1. So let's write down what we do know. With my marker that I don't know where to put it. We know T30 equals 58. We know S30 equals 1095. And we need T1. We also know between both of these n equals 30, right? For both of them. What formula uses S of that value, uses T of that value, so Sn and Tn, and uses n? The second sum formula, right? So we have Sn equals n divided by 2 T1 plus Tn. Most people don't spot this one right away, but if you think about it, it would be S30 equals 30 divided by 2 T1 plus T30. And I know T30 and I know S30, so I can substitute them in, right? And the only thing I'm missing is T1. And what are they asking me to find? T1. So S30 is 1095 equals 15 times T1 plus 58. I personally, you could distribute the 15 in and then solve. I'm going to divide the 15 over first. 1095 divided by 15 is 73. Equals T1 plus 58. Subtract 58. And T1 equals 15. Make sense? Once people fill the 30s in, they'll spot it. But until you fill the 30s in, people are like, I don't know what formula even uses those things. So the best way to learn this stuff is by practicing, giving a whole bunch of different examples. Because I can stand up here and do all the examples, you'd be like, oh, yeah, that makes sense. And then you get to your textbook and you try one, you're like, I don't even know where to start, right? So practice. So here we have T1 equals 11, so we know the first term. Here we know the last term, Tn equals 119. We know the sum of the terms up to the last term, 1235. And they want n. What formula has T1, Tn, Sn, and n? That same formula. Second sum, arithmetic sum formula. So Sn is 1235. N over 2. T1 is 11. Plus Tn is 119. So we have 1235 equals n over 2 times 130. What I would do first, personally, is multiply by 2. People are like, I don't know why you can do that. Well, this actually can be written all over 2, just like this, because this is over 1. The whole thing could technically be over 2. So you can just bring that 2 up, multiply it, and get rid of it. So 1,235 times 2 is 2,470 equals 130n, and then divide by 130. N equals 19. So technically the 19th term is 119, and the sum of the first 19 terms is 1,235. That's what that means, right? The last example I picked because it's more like a grade 12 example. It has variables, and you're expected to know how to use them. So it says the first three terms in the arithmetic sequence are given by x, 2x minus 5, and 8.6. So we need to determine the first term and the common difference. Well, what's the first term? T1 is x, technically, right? What's the common difference? Well, we can go second term minus first term, or in this case, we could do third term minus second term because the third term doesn't have a variable, right? So we could go T3 minus T2. This is what everyone does. That's wrong. What am I forgetting? Sorry? Brackets. Because right now I'm just subtracting the 2x, and I need to subtract the whole second term, right? So I need to have brackets. So you get 8.6 minus 2x plus 5. So negative 2x plus, what would that be? What's 8.6 plus 5? 13.6. So you guys, this common difference, if I wanted to actually find out what x was, we had a question like this in the homework from Monday. If I want to actually find out what the common difference is, what that x is, I can find the common difference between the second and the first terms as well, right? So let's do term 2 minus term 1. So the common difference would also be 2x minus 5 minus x. So the common difference is also x minus 5. Why are they different? Because depending on what x is, when I fill it in, the common difference itself will be the same number, right? So can we figure out what that x would be? This is the common difference, and so is this. Could we not set them equal to each other? And solve? So you could go negative 2x plus 13.6 equals x minus 5, because they're both the common difference, so they could both be equal to each other, because you can say d equals d, right? Move the 2x over, and I get 13.6 equals 3x minus 5. Add the 5, and I get 3x equals 18.6. Divide by 3, and what is x actually? 6.2? Yeah. So if I want to know the actual first term is 6.2. What's my actual difference? Is my difference 6.2? No, that's my x, right? My difference is 6.2 minus 5. So it's 1.2. If I filled it into here, I go negative 2 times 6.2 plus 13.6 is 1.2. Same answer, okay? If I plug it into this x. Does that make sense? That was a question from Monday where people said one of the questions was solve for x, and you were just given a sequence. What you had to do is take term 2 minus term 1 to get the common difference, term 3 minus term 2, get the common difference, and set them equal to each other and solve for x. So if you don't know what I'm talking about, you skip that question in the homework. I'll leave B and C for now. From your actual homework assignment, mark these ones down. So we did 1 to 3 yesterday. 4, you have to do D. 5, you have to do B. 6, you have to do B and D. What does multiples of 4 mean? What do I start at? 4. Multiples of 4 means I start at 4 and it goes up by 4. So your D value would technically be 4. So you start at 4, and the next multiple of 4 would be 8. The next multiple of 4 would be 12. So if it says multiples of something, you have to do that. Okay? 7A. Remember, if you're ever stuck at a definition, you have your phone near you, most of you. It's like part of your life. So you can always like Google it if you're stuck with a word terminology, right? And then just, I want you to do 10. I assigned 11 already. And 20. That's all I want you to do. The rest is extra.